Welcome back to Gene Online. This is the video of Unit 8 of Digital Fluency course. So here we will see how to implement a neural network, and we will also learn the detail all these steps that is followed by a neural network to learn any task using dataset. So let's start now. Let me share my screen and okay, so here as you are seeing that there is a neural network diagram where the first layer where you have three circles of the blue color, x1 x2 up to xi. This is the input layer, and which is connected to the output layer, which are shown with using a red color circle, b1 b2 b3 and up to bj. And the output here is y1 y2 y3 and up to yj. And the connection, each input neuron is connected to all the output neurons using weights. So these weight connection you can see here, that weight is denoted by using wij. That means ith node of input layer is connected to the jth node to the output layer, and the value of this W indicates the strength of the connection between ith and jth node. So this is how the connection is made between input and output layer. And what happens, how actually model learns the features which is present in the input layer, that we can see here in the forward propagation. That so here you can see the information flow from the information flows from the input layer to the output layer. So here that flow is called forward propagation. And whatever the output is calculated from the output layer, those outputs are compared with the ground truth output, ground truth values, and that difference between the prediction output and the ground truth output, that difference is called error. And that error back propagates through the network. That means it actually back propagates from the output layer to the input layer. It is a backward direction. So I hope you have understood how the information flows from input layer to output layer, and the error gets back propagated from output layer to input layer. Okay, so let's see a little bit more detail how the forward propagation happens. What does that mean? So here you can see yj is equal yj. That means the output of the jth node in the output layer. How does it calculated? Bj is the bias that gets added into the x summation over I xi into wij. So this is how the calculation happens. This is the mathematical formula behind each output layer, each output node. And so here you can see there is a dot product between xi and wij. So this can be represented for a single neuron, but to represent the entire network, we use matrices. So here X represents the all the input values, and from X1 up to Xi, and W is the connection from each neuron in the input layer to the each neuron of the output layer. And B is the matrix of the biases, and here is the calculation. Y is equal to XW plus B, and that's it. So this is called forward propagation. And what happens in backward propagation? So here we actually calculate the error. Error is nothing but the difference between the output of the network and the ground truth. So though that error gets back propagated through the network in the backward direction from output layer to the input layer. So in the derivation of the error with respect to the parameters. So how do we back propagate the error into the network? Actually, we differentiate the error with respect to parameters. So the parameters, we call these W's as the parameters, and the error is differentiated with respect to each W, each parameter, and so on. So as you can see here, the error is differentiated with respect to W, and this is the calculation. And after that, all these, the same thing happens corresponding to each layer. So whatever the output of that layer, that will be back propagated and differentiated with respect to the immediate weight connection. And it is a chain rule that we follow to calculate the gradient of the error. So after calculating, so this thing is the layer by layer error is differentiated with respect to the learning parameters. And once everything is calculated, weights are we update the weights using equation, using optimizer like W is equal to plus and is equal to W plus or minus delta W. So here we have understood the back propagation, how the information gets updated using the error through the network. Let's understand the code. So here there is a code for forward back propagation and backward propagation. So input error and the weights error. And here we update the weights and the biases using learning rate. So as you can see that the weights is equal to weights minus learning rate into weights error. So here the update parameters that you are able to see. So yeah, here in the back propagation, we also let's understand about the activation layer. What does the what is the meaning of the activation layer? So activation layer is used to bring the non-linearity in the output of each layer. So output of each layer gets it learns the non-linear relationship between the input and output layer using activation function. So some example of activation function is like sigmoid, softmax, 10H. That's it.